Hey, Mzansi coders. I hope you guys are doing well. So today actually going to be looking at scaling up to million of users, right? So this is just to say, how can we build an application that can be used by millions of users, right? So it's pretty much a good, um, I'll say a good video if like you're preparing for your system design interview, or you someone who just want to learn about how to actually build an application that can be used by many people. What are the things that you should always think about, right? So cool. With that out of the mind, one thing that we're gonna start doing is to actually start with a single server setup. Then as we go along, we're gonna like get into more complex stuff, right? Just starting small, then we're gonna incrementally increase the complexity of the application. For now, you can actually think of like we have like a simple side with a single server. So just gonna write the user here, which they can actually access our site on two platforms. I'll say it's whether web or it's either mobile, right? So for them to actually access our site, they're gonna have to then use our domain, Mzansi coders. Then it's actually gonna then if they use the Mzansi coders, then they're gonna have to get the IP address. So using the domain name system, right? DNS. So this will then return an IP address. So this IP address will actually be used by these users to access our server. Okay. So for in short, internet IP address just stand for internet protocol, right? So after they got this IP address, they can now use hypertext transfer protocol to actually make a request directly to the server, right? I'm just gonna write IP address here. So using the HTTP, they can now send a request directly to the server. So you can think of this as our server, right? This is like our logic. Then the server in return, it will just return, it could be HTML page, so it could be HTML page, or it could be a JSON, right? Like maybe they were looking for a number of users, like give me number of product. You can imagine that you have access like Amazon site to buy a book, so you can like get that JSON response. So yeah, like it can be a JSON, something like this, whereby you have like the ID of the user, it could be number 12 here, something like this, right? Then we have maybe a book name, something like this. Then you have the name of the book, right? Just go to the client side. So now you can actually think of like we're growing up, right? Like we have so many customers and we kind of like need to store the data of our products and customers. So I'm thinking of actually having a database, right? So we're gonna have one database there, and now the server will actually read the data and write the data inside there. So it's gonna be read, write, and it's gonna have like the update capabilities, and the database will just return the data itself. So that is required by the server. Just gonna return the data. So you still remember like the user can say, I'm looking for this product, right? Then that product can be returned in a JSON, like ID, could be product name, like the product information. Every time you go to Amazon site, you're gonna get all the product returned to you when you access the site, right? So it could be product name, it could be books, all of this information will then be returned to the client, and it's being stored in the database. Okay, so speaking of databases, there's been quite a lot of use cases like for different companies whereby they're using different databases for their OLTP systems. So because of we require a transactional database in this case, what happened is MySQL, Postgres, they've been quite used in this use case, right? So these databases, I'll actually consider them to be row wise. So by row wise, I mean they store data in a row fashion, so pretty fast compared to like analytical databases, OLTP, right? OLTP, I'm referring to Redshift, like your BigQuery, because these are column wise databases, right? So how they store data in a column fashion, so they are very good for analytical purposes. So hence these relational database like MySQL, Postgres have been quite used in this use case, whereby we just want the customer to buy something, transaction. So they've been quite there in the industry for some time. However, there's been also changes whereby some companies have option to use non-relational databases, like these could entail databases such as Cassandra, MongoDB, so the reason most of the companies have used these because they require super latency, like low latency, whenever essentially you're gonna write, especially also because now we are in the big data environment. So these databases can actually also handle unstructured data, right? So that's like a massive advantage also. So like then that means then you can store a massive amount of data, so to speak, right? So you can store a lot of data in it, right? Okay guys, let's just look at like how we can actually scale our application, right? So let's say like we had like 5,000 users with the like current architecture, and now the users have increased to 10,000, right? Then the question is, how do we then scale the application? So there's two ways of actually going about scaling, which before we go into this, I would actually like to explain the two method of scaling, because if we try to understand them, then we'll be able to understand about load balance and why do we need two servers. Okay, so the first one, it's vertical scaling. So vertical scaling is actually trying to increase the size of the server. So you can imagine that our server had a very little CPU, then we're just going to increase the CPU, we're just going to increase the RAM, we're just saying let's increase the power of our machine, right? So whereas horizontal scaling, we say we're gonna then add more machines, like we're gonna like scale more machines, we're gonna scale by adding more machines, like in a horizontal manner, right? We're just gonna add more machines like this, right? So we're gonna have more machines. So whereas vertical scaling, just say add the power to the current machine, just like that, right? We had this, then we're just adding more power, just like more CPU, right? So however, I would say like the vertical scaling has a drawback, because you can add like more power into it, but if like the machine dies, like let's say like everything is gonna shut down, like everything is gonna crash, right? Meaning that your site is not gonna be as accessed, right? So if it crash, then everything is down. Like your users, they're not gonna be able to access your site, right? So what happened is that we tend to option for horizontal scaling, because it gives us that, okay, if one server dies, we still have three, right? And the good part is that we can now distribute the traffic to these remaining servers that are there. Okay, so that's why we tend to option for horizontal scaling, right? Now that you understand the two part, like the two techniques that we use to scale, so we're gonna go to number 3, whereby we say that every request that we get, like I said, now we have like more requests. Our users are buying our product. Then we're gonna load balance that traffic. We're gonna like distribute that traffic, like using the load balance to different servers, because we're using the horizontal scaling technique. Okay, so you can think now we have this public address that our user are getting it from the domain name system. So they're getting it from there. Then the domain name system gives them the public address 8.8. Then they're using that public address. They hit our load balancer. Then our load balancer produces the private IP addresses internally. Then those IP addresses are redirected to specific servers. So the load balance is quite like clever. That's why they're calling load balance. So it balances the load, meaning that if we have like 10,000 requests, it will make sure that the 5,000 goes here, the 5,000. So it will try to balance all the requests. So it wouldn't send like all the requests to one server, because that might crash one server. So it'll always try to do that. Okay, so that's why we always that's how like we scale the server portion. Okay, so even if like one server goes down, like we still have one server remaining, so our side will necessarily go down, so we still online. So that's also the advantage of going with our horizontal scaling. Now guys, I just want to talk about like, because now we have actually replicated our server. If one server dies, we still have another server, but we've never actually spoke about our database. If you can remember from our first architecture, so if this database here dies, like it goes down, then essentially we can't read or write or update our data. Like we lost our customer information, we lost our product information. So we have to do something about this, right? This is the new I'll say chapter, which is data replication, right? Like how do we then go about distributing our database, right? So we make sure that the data is not gonna die. So I'm just gonna take a few seconds here just to rant about data replication. So there's quite a few techniques about going this, but the one that I just want to talk about is the master slave technique, whereby we're saying that, okay, there's going to be a master database whereby our writes are going to be, and we're going to have this slave whereby our reads are going to take place, right? So you can imagine that every time someone buys our product, that transaction, like that customer information, that transaction information is going to go to the master database. And every time our customers access our site, whenever we give them that information to show them which product we are selling, then that read is going to go to the slave databases. We can have multiple slave, like 10 or as many as you want, right? So why are we doing this? I'll say like better performance is one of the reasons, because now we have like a lot of, I'm just gonna draw a simple architecture here, but before I do that, like I said, I just wanna go about like talking about why we are replicating. This is a very it can be a chapter on its own, but at the high level we can say like better performance, because we know that we're scaling our reads, right? Like meaning that customers can read from like like if there is more traffic, then they can like read from these databases that we have actually scaled. Then there's reliability, because if one database dies, because we know that we're always gonna have another database with like replicated data, so we're not gonna lose anything, right? Like high availability has been also a very important thing, because we know that our system is always available. It will never crash. It will never, because like we know that if one that slave goes down, we can now the customers can read from the other slaves database. Okay, so those are the main important concept that I wanted to raise. So how does this thing work? So essentially, all the servers, we can think of these servers here, they're just gonna like read from like what I was telling you about now, like this database here. We just called it slave. We can have as many as we want. Like we can have multiple slave inside here, right? So we can have all of these databases. And then we also have like these master. We all can only have one master. So database. So I'm just gonna write master DB, whereby now all the writes, like I said, these are the reads. Like, customers are reading the data inside here, inside the replicate. So all the writes are just gonna happen here. So these are the writes, like I said, customer transaction. And then whenever the writes take place, how do we make sure that this data that is inside here, it can also be found in the slave? Or like we just replicate the data all the time. There's write, so data is being replicated, so they are in sync, meaning the slave has to make sure that it has the current state of the master database, so that the users all the time, whenever they get the data, they get the timely and recent data. So that's how like we kind of like replicate the data. Okay, so how does this thing then, like, how do we then handle a failure of the master? So all the time, if a master goes down, let's say this dies, then where will the writes happen, right? So what happened is that we always take one slave, then we promote one slave to be the master. So I'll cover this into more detail. Like I said, data replication can be a chapter on its own, because there is like scenarios whereby they might be a lag. Like, let's say we promoted this slave and now it didn't get the current data that was in the master DB, and like there's a lot of disadvantages that could happen, but there's a way also of like overcoming those ones. But for now, just know that every time the master database, we just promote the slave, right? And like the slave always knows, like we're using logs, so it knows that, okay, if it goes down, like let's say it crashes, maybe it goes through a maintenance, when it comes back, it's gonna use the log to know that, okay, I was actually on ID maybe 45. Then I'm just have to catch up. So it's gonna ask the master data, the master DB, to say, okay, give me all the data from 46 and onwards, because I was on 45. Then it's gonna recover and get all the data in recent state. Okay, so how then does this thing flow? So like like I said, like we firstly get the IP address, then like we load balance the traffic, then the web server will essentially have to like write every time there's writes the master DB, then the reads will then happen to the slave. Okay, so we're gonna be talking about cache, right? So cache is a temporary storage area that stores the result of expensive responses, right? So, like in a site, there's always that data that is frequently accessed. Like, let's think of our e-commerce, whereby we're selling products. Let's say our customer access our e-commerce, and as they're accessing our e-commerce, like they buy products, then they keep on adding these products to our cart service, right? So like, like customers, they're going to continue to shop and they're going to continue to add those products. So that means card is going to be this service that is accessed mostly. So it will be good to kind of like cache that data. Like by caching, I mean like store that data in memory, so that it's easy, it's fast to access it compared to a database. Okay, so like the reason we're doing this is because reading from the database is quite expensive. Also think of that the data in a database is stored in a disk, so it's gonna be it's not gonna be efficient to read from database all the time, especially for frequently accessed data. So that's why we're gonna introduce our new service here, gonna call it cache. So this is like a system that stores data in memory, right? Like we can think of Redis. So it stores the data in memory. So how it works is that every time the customer comes to the server, like, they making request. So we firstly check if the data is in the cache. If it is in the cache, then we return that data. It's going to be fast compared to the database. Like I said, it's stored in memory. But if the data is not in memory, what will happen is that it will get the data in the database. Then that data will then be stored in cache, right? Then it will be cache. This is a technique which is called a read-through cache, right? Like, because we just reading through this, then we check to the DB, right? So before we move on, I just want to say, like, so you have to be careful about how you design these two components, because they are two separate databases. So, like, then how you need to ensure you keep the same state in Redis and in your OLTP databases, because if there's a lack or there's a change of primary keys, then this might actually affect you in the long run. So, like, you can actually use a real-time processing layer like Kafka, like, to kind of like every time make sure that the state of the DB is also is replicated in Redis. So just make sure, because I've read of a use case, I think it was on GitHub, I'm not sure, I can't remember, but essentially the master database crashed, and when I think it got back, there was a lag around the primary keys. Then the primary keys that were in Redis did not match the one that were in the OLTP database. Then some of the privacy information about customers were revealed to different customers because of, like, the primary keys and stuff. So hence I'm saying it's quite important to make sure that you maintain the state. Okay. So the rest of the things that you should consider about caching and caching systems use the expiry policy, right? Because we're storing the data, in memory. So, like, you should think of, like, when you're gonna get rid of that data in memory, and you should think of, like, how long you should keep it there, right? Like, that's the most important thing also. Expiration policy, you shouldn't make it short, you shouldn't make it longer. It depends on the business use case, but those are the things that you should consider. So the second component that I want to talk about, it's like the CDN, right? So essentially now we're thinking of, like, okay, we've cached the data, but then how about we also cache the static files, like, JavaScript, CSS. So this is also what is known as content delivery network, right? So we're just saying we just wanna cache all the static files like JavaScript, React, and all of these things, right? So you're just gonna put them inside here. So the reason we're doing this is because we want these static files to be accessed quickly. So let's think of a use case. Let's say our user is in Johannesburg, they're in Johannesburg. Then we have, like, a CDN in Johannesburg. Then, like, that data will get that user is going to access those static files from our content delivery that is stored, that is in Johannesburg. So if some of our users are in Cape Town, then we're going to have another CDN in Cape Town, just another server of CDN to store our static file. Then those users are just going to get the user interface and, the UI whenever they're accessing our site from that. So it's much fast. It's like unlike getting it from the server, because as much as you're getting it from the server, the user might have a bad experience because of the loading. Every time they want to access the site, there's always going to be a loading and all those kind of things, right? So very important CDN, especially when we're scaling our application. Okay, guys. So now we actually going to have to look at the stateless web tier, right? So what do I mean by the stateless web tier is that each server stores a session about the user. So now you can imagine, because we have distributed our server, so that means if the user they come again to the site and they are redirected to this website, to this server here, then what will happen is that it will fail. It will reject them because their session data was not stored in this server. It was only stored in this, right? So this is what we call a stateful architecture. So let me just show you a simple diagram so that you kind of like get an idea. So they say this is our user, and they're accessing our server. This is server 1. So this server here, it will try to get the session data, like session A for session user. So like, get all the other information like images of the user and profile, but it wouldn't actually, the other servers that we said we distributing, like this is server 1, this server 2, won't actually have access to that session data. Like this session data, it won't actually have that information. So the user, when they come back tomorrow and they then redistribute it to the second server with our load balancer, then they're not going to be authenticated because of this problem, right? So how do we then create a stateless web tier? Like how do we make sure that our web server does not necessarily rely on the server? So we have this, we can actually store the information, the session data, in a shared storage, right? So this is a shared storage, meaning that all the data, all these servers that we have, no matter how many they are, they all gonna be, all this session data will also have to go inside here. All of it, right? None of these servers are gonna store data by itself. All of this data will have to go into our shared storage. So this can be MongoDB, can be NoSQL. So it like literally, but I'll go with MongoDB in this case. The point here is that like all the data is stored in MongoDB. Then all of these servers, every time the user comes here, then they can use this. So now they are becoming more stateless. So we can scale this, right? So it's very important to think about this. I think in the second tutorial I will create a Node.js project whereby I'll teach you guys about like sessions, how they work, and we'll build a project and showing you what I'm talking about. And I think it will be something cool. I've never seen something like this. So I'll show you how to build something like this. And yeah. Another chapter that I'm actually gonna look at, guys, is actually distributing our service like internationally, right? We have to think of like now all this time we have been operating in like South Africa. So let's say customers in North Africa, I mean to say, they want our service, like, so we can build a data center in Nigeria, and in that way customers from Kenya, they can now be routed to that data center because it's close to them. So that will be fast than them actually reading from South Africa, if that makes sense, right? So the goal here is just to say we're gonna now redistribute this portion that we have internationally. So it's not supposed to be in every country. Like if you can have 2 data centers in Africa, that's okay. We can have one in like South America or something like that, right? So in that way, like now, like our request can be geographically redistributed. Let's say there's a customer here, so they can, whenever we understand where they are, then we're gonna distribute their request to the closest data center. So we use what we call GeoDNS. So it's a DNS service that allows domain name to be resolved to IP address based on location of this user, right? So if like is in Brazil, then we're gonna use the data center is that side, right? So that's the point with like this. So, but however, you still remember that the shared state that I was telling you about of the servers. So we should make sure that it's actually outside of the data centers, because if it's inside one data centers, then another data centers might not have a session of like all the customers. Okay, so the shared storage that we just spoke about should be outside of a data center and be distributed. Then every data center can actually access it. Okay, so yeah, I think that's all. I think I'll definitely, please know that like there's more into this, like you can talk about, like, because they obviously like distributing servers like international, like there's more like admin work that has to be done, like test and deployment, data synchronization, traffic redirection. Like there's more things that we can actually go about talking about them inside here. Just giving you guys like an overview, and I think as we go on, what we're gonna do in this channel is that we're gonna like start focusing on like one component. This was just like an overview of like how you can like build, scale, and like scale your system to, let's say, 1 million users, right? So I hope you guys enjoyed this session. I'll definitely like build more project, like build actual apps, and just to explain these concepts in more practical way, so that it's easy for you guys to kind of like understand also from a practical point of view. Okay, so thank you for tuning in, guys. Take care. Bye.